Hey guys, welcome back. So this short video is focused on Lesson 7 in AC Theory 1. It continues on with capacitive reactance and how to factor it in a circuit. Now I'm going to hit a couple questions in this lesson to highlight the fact of making sure you get your decimal point correct. First, I'm going to go ahead and start with question 11. Now, I've got the answer key up here because what I wanted to show you guys is two different ways to factor this. Now, they give one way here, and it is using 0.0002 for 200 microfarad capacitor. And I want to remind you guys that if you're getting tripped up by moving that decimal place, stick with the theory of convert microfarads into farads when you do your calculations. You'll have to enter some more twos or zeros, but it is a safer way to go. But what I want to do with this is actually show you guys that we can calculate it with microfarads as long as you move your decimal place at the end of the problem. So the capacitive reactance again is going to be 2 pi FC under 1. So on the calculator, let me turn it on, clear off what we had here previous, and they say that we have a 60 hertz source and 200 farads, microfarads of capacitance. So I start off with my 2 pi 60, and I'm going to go ahead and multiply this by 200 and hit the equals button. Now, because I just did this portion of the equation, now I have to do the reciprocal part. I hit the reciprocal key and equals, and I get this value right here, which is 1.000013263. Now, because they're asking us for a capacitive reactance of a 200 microfarad capacitor, and I factored in microfarads, I would take this and move the decimal 6 places. So 1, 2, 3, 4, 5, 6. So it would be 13.263 ohms of capacitive reactance. Looking back at the problem here, 13.26 gets rounded into 13.3, which is the answer they're looking for. So again, that was a quick run through of either using microfarads for your equation or converting it into farads. A couple of different ways to do it. Looking back at your lesson, I would like to then help you with 14, because 14 is a two-step problem where they're asking you for capacitive reactance and the capacitance of the circuit. So the first step that they say is just like we learned previous, once you have capacitive reactance, you can figure out you can substitute it into Ohm's law. So being that they gave us a circuit voltage of 240 volts and a current flow of 2 amps here in the problem, we've got voltage, we have current, That means we simply need to take 240 volts divided by 2 to get a capacitive reactance of 120. And that would actually be 120 ohms of capacitive reactance. Once we have that, the next step is asking us for the total capacitance. Now, this is very similar to a question in a video that I covered with inductive reactance, but if we go to the whiteboard, we got to remember that capacitive reactance is equal to 1 over 2 pi Fc. Now, we've already found out that the capacitive reactance is equal to 120 ohms, and this doesn't change. The frequency that we were given in our problem has a frequency of 60 hertz, but it is the capacitance that is the question. So again, this is where we have to use a little bit of Ohm's law to switch the formula around. Now, in inductive reactance, it was a little easier because it wasn't a reciprocal formula. But because the capacitance is on the denominator, we can then swap the capacitance for the capacitive reactance. Now, how that's done algebraically is because this is a divided by. If we pretty much take the capacitance, and if we were to, say, multiply by the capacitance over here, we would cancel this out. But then we have to multiply by the capacitance over here. Well, that still doesn't give us our unknown by itself, because then over here we'd have to divide by 120 to cancel this out, but we'd have to do the same thing over here. But because 120 needs to be divided by the solution of this whole thing, we can just add that 120 to the equation right here in the denominator. So then we get capacitance is equal to 1 over 2 pi 60 times 120. And that is how we'd figure out what our capacitance is in question 14. So let me show you how to factor that in. It never hurts to practice the calculator a couple more times. So turning this on, clearing it out. What I'm going to do is start off with 2 pi 60 for our frequency, and then multiply that by 120. I'm going to go ahead and equal that out, and then because it is on the denominator side, I still have to find the reciprocal. So go back to the calculator, hit the reciprocal of the answer, equals. Now, that is a capacitance of 0.00022. So we have to convert this into microfarads for our answer, and that just means moving the decimal 6 places. So 1, 2, 3, 4, 5, 6. Looks like 22.105 microfarads. And going back to the question, they do ask us to round it to 2 decimal places. So don't forget to round that to 2 decimal places before entering your answer. Now, I hope this has really helped you guys with just a quick rundown of factoring capacitance or capacitive reactance. If you have any further questions, don't hesitate to give me a call, and I'll see you in class very soon. Have a good night.